And we'll begin with a couple of announcements. The grading scheme has been set, and Lab 1 is available now. Lab 1, I suspect many of you may have done a lot of it already if you've installed Eclipse and a JDK. That's basically Lab 1. You have to hand in a very small little program, but if you hit the link here and look at the assignment, look at the lab, you'll see that it's very straightforward. Let's look at the grading scheme quickly. So if you go to Content, and under course description and requirements, right? You can find things like the syllabus, the description of the course, the textbook, and things like that. But right here, you'll see a table that describes or that lists the elements of the grading scheme. So there's going to be 10 marked labs. They're all going to be, I mean, the labs are only 2 hours long. The plan is that you can finish it inside of 2 hours. So the 1% each, for a total of 10% of your marks. First assignment should come out later this week. It's basically going to be take a Python program and translate it into Java. So you're just, I'm just getting you to transition from Java into Python. So there's no actual, you don't have to do any original computational thinking sort of thing. It's just pure translation. And then you've got another 4 assignments worth a total of 40%. There's a midterm. It's going to be the Friday before reading week. On cue during your lecture time. And then finally, there's an exam. Its date will be set by the exam office. Right, so that's all available to you now. And I think that completes the syllabus. I have to give you the assignment dates or the approximate dates, but other than that, that should complete the syllabus. All of the information for the course is here under course description and requirements. All right, so the lecture for today is about now, as Python programmers, you know all about lists. You should know about tuples and dictionaries as well. Sorry, gotta let somebody in. Hang on. So a list in Python, you know, is they're very powerful actually, right? So they let you store a collection or a sequence of any item. I suppose I should use the proper terminology. So in Python, a list is a sequence of elements, right? You can access the elements using indexing, right? So using the square bracket notation, right, and an index, you can access any individual element. Python is interesting in that you can slice a list, so you can get a sublist from a list very easily. Again, using square brackets and an indexing type notation. What else do I want to say about lists? I guess there's the notion of the last element in the list, right? So if you want to get the length of a list, you use the function called length in Python, right? The last element, because we index starting at 0, the last element is the index of the last element is the length of the list minus 1. Right. You also know in Python that you can, well, you might know that you can use negative indexing. So -1 means the index means the last element of the list, right? So the first element from the end of the list. Yeah. So that's how you use that's the very quick introduction to a Python list. Now, Java has 2 things that sort of look like Python lists. So the first thing is called an array. Now, an array looks like a Python list in that it uses the square bracket notation to access elements out of an array. Java also has a list type, but the list type, it doesn't have that nice square bracket notation. So a Python list is kind of a mashup of a Java array and a Java list. So you now have to go back. Now we're going to go backwards a little bit from Python. So if you want to use square bracket notation, you have to use an array. If you want all of the nice functional power of a Python list, you have to use a Java list, which means you can't use the square bracket notation. So we're going to start with arrays, and lists will come a little later on. So in Java, an array is a container object that holds a fixed number of elements of a single type, right? So that's different than a Python list, right? Python list, you can add an arbitrary number of values to the list, right? And you can store whatever element type you want in the Python list, right? In Java, it's a fixed number of values of a single type in an array, right? So when you make the array, that's when you establish how many things the array can hold, right? So the length or the capacity of the array, that's defined when you make the array. Okay, so to make an array or to declare a variable that can store an array, right? You write down the element type that you want to store. Then you put a pair of a pair of square brackets with nothing in between, and then you give your variable a name. Right. So in this example here, collection is an array of type double, right? Or collection is an array of double values. Sorry, collection can store an array of double values, or point to or refer to an array of double values. Right. So right now there's no array yet. Okay, there's a variable, and we can make this variable refer to an array. Now, Java arrays are much less flexible than Python lists, but they use the square brackets for indexing. Right. So in particular, you cannot slice an array. There is no negative indexing. Right. So if you try to use a negative index with a Java array, you get a runtime error. And your element type, you have to specify the element type, and you're restricted to a single element type for the elements in any given array. You can use, so I'm going to tell you, I'm going to explain more about this in a moment, but you can use the braces and then a list of elements to initialize an array, right? So when I declare my array T, on the same line, I can write equals and then braces and then the list of elements I want to store in the array, right? So this tells the Java compiler to make an array of length 4. Right, 1, 2, 3, 4 elements. Right, so T now refers to an array of type of for-car. Right, so that's what that means there. Using the square brackets, you can get the first element of the array, for example, or you can get the last element of the array. Right, now notice another difference relative to Python. Right, Java does not have a function called len. If you want to find the length or capacity of an array, it's the array name dot followed by the word length. So every Java array has what's called a field named length that stores the length of the array. Right. So t.length in this example is 4. Right. The last the index of the last element is 3. Right. And the last character or the last element in the array is the letter D. Right. You can change elements in the array. So using square brackets, you can do assignments. So these all look like working. These are all similar to using a Python list. Now, when you use the braces to list the elements of an array, this is called array initialization. Right now, initialization. Right, initialization means. Right. At the point of declaration, you can say what elements are in the array. Right. So at the point of declaration, you can do this. If you do something like this, right? So make a variable, right? U. On the next line, you are not allowed to write U equals something. Right. Sorry, you're not allowed to write U equals braces some sequence of elements. Right. So this is not initialization. Right. In Java, we say that this is assignment. Right. You're using the assignment operator on an existing variable, and you're trying to make it refer to this array. That doesn't work in Java. Right. So the braces are only allowed for initialization. Now, to actually make the array, if you're not using the initialization syntax, you use what's called the new operator. To create the array. Right. So in this example here, right, I've got a variable called collection. Collection is allowed to refer to an array of double. So on the next line, this is where I actually make the array. Right. So I create the array of double by writing new. Right. So use the new operator, element type, square bracket, length or capacity of the array. Right. So now, so this expression or this statement here actually makes the new array object. Right. So it allocates memory for the object, stores it in memory somewhere, and then collection equals. This thing means that collection now refers to that array object. Right. So in Java, arrays are not primitive type. Do not have primitive type. Right. So arrays in Java have reference type. So if you have an array that stores primitive elements, right, then all of the elements of the array are given a default value when you use the new operator. So for example, here some bools, right? That's an array of Boolean. Right? So when I make my array object here, right? So I make an array of 3 Boolean values. The 3 elements of the array are automatically set to false. Right? So some bools is actually an array of 3 false values. Here, when I make my array of int, right, some ints refers to an array of 4 0 int values. Right? And finally here, when I make my array of double, some doubles refers to an array of 5 double 0 values. Right? So when I print these out, so here I'm using system.out.println, right? When I print them out, I'll get false, false, false. I'll get 0, 0, 0, 0. And then I'll get 0.0. Well, I'll get 5 0.0s when I print out some doubles. Now, if you try to print out the array on its own, so if I write system.out.println and just some bools, what you end up with is a very strange result. Right? You end up with some string made up of numbers and letters. And it turns out it's actually the memory address of the array. So if you actually want to print out the elements of the array, which is what you normally want to do, right? You need some method, or you have to write your own method to actually print out the elements of the array. So the language, right? The Java library gives you this array, gives you a method called arrays with an S. That will take an array and return a string that represents the elements of the array. Right. So in this case, it'll give you square bracket, false, comma, false, ending square bracket. Right. So it puts the elements of the array as a comma separated list inside of square brackets. Right. So remember, when you want to print out an array, you should call the arrays to string method and pass in the array that you want to print. So when you make an array of primitive type elements, the default values are shown in this table here. Right, so all Boolean values get initialized to false. All of the numeric values get initialized to 0. Right, so whenever you make an array using new, the array is already populated with some default values for you. Now, the default values aren't always the values that you want. So if you want some other, so if you want to fill the array with some other value, you should use the method called fill. That's also defined in the arrays class. Right? So your arrays class is actually that thing here. So the class arrays is defined in what's called a package. Right? So we'll talk more about packages a little later on. But the package that's defined in is called java.util. So all of the Java standard library classes are in this package called Java. Right? Inside the package Java, there's another package called util. And this is where all of the useful or utility classes exist. So the class called arrays, right? So array with an S. This contains methods that operate on arrays. Right? So things like toString and things like fill. Right? And a bunch of other very useful methods that operate on arrays. These are all defined in, sorry, someone's, once we have defined the length of the array, is there a way to increase? Okay, so I'll answer Daniel's question in a minute. Right, so several useful methods are defined in this class called arrays. Arrays is what's called a utility class. In a utility class, all of the methods are static and public. So that's why you use the class name to call methods like toString and fill that exist in this class. So Daniel says, once we've defined the length of an array, is there any way to increase that value later? So no, once you make an array object, there is no way to take the same array object and make it bigger. Right? So for example, when I make this array object over here, that's an array of length 10. There's no way to make that array, there's no way to change the size of that array. Now what you can do though, is you can take some doubles, right? That's a variable that refers to array, right? You can make that refer to a different array that's bigger. Right? So if you have an array of say 5 values and you decide, oh, I really need 10 values, right? Then what you can do is you can make a new array of length 10, copy the 5 values out of the first array into the new array, and then say sum doubles equals that new array. Right? So that's what you can do. That's what you need to do if you want to change the capacity of an array. Josh asks, can we import a singular function like we would be able to in Python? So no, you can't import a single method in Java. So you can't write import Java util arrays dot fill. What you can do though is you can import all of the static methods from a class. So there is a way to use what's called a static import statement to import all the static methods. If you do that with arrays, then you can just write toString and then you can just write fill. You don't need to use the name arrays. Generally discouraged from doing that. The problem with doing what's called a static import is that if you do that by habit, so for example, suppose you have a bunch of classes that you're using that you need to import, and you use a static import to import all of their static methods. If two or more of those classes have a method of the same name, your class will no longer compile because the compiler can't figure out which static method you're referring to. Right? It doesn't know if you want the method from arrays, for example, or it doesn't know if you want the method from the other class. So generally, you're discouraged from doing that, but sometimes it is useful. You said that car has the default value 0. Is that no, Stuart? So the back here. This is the weird thing with car, and this is the same problem you run into in languages like C. So when you think of car, you think of like symbols or letters, right? So you might think it's the car. It's the car corresponding to the digit 0, right? It turns out that's not true. So the car corresponding to the digit 0 actually has a numeric value of something else. I don't remember what the value is, right? When the car value is the numeric value 0, that means something else. So if you actually try to print out a car whose numeric value is 0, it doesn't print anything. So it's what's called a non-printing character. So it's not the same thing as the digit 0. If you want the digit 0, it's single quote 0, single quote. Arrays.fill works with any type of array. So Arrays.fill, I should show you. Hang on, let me do this way. At some point, there's a notebook that tells you how to read the API for a class. I haven't done that yet, or I haven't shown that to you yet. But I'll show you the API for arrays today, right now. So if you, so the Java language is nice in that Java was one of the first languages that standardized how its documentation should be written. So if you read the documentation, so if you access the documentation for anything in the standard library, it always looks like this, right? When you write your documentation for your own classes, it ends up looking like this, right? If you want to find out how the arrays method works, you can just Google for Java space arrays with a capital S. Pick your version of Java. So I'm just using Java 8 to find the documentation for this particular, for the Java version. And then you end up with this web page that looks like this. If you go and look at fill, So you can see there's a lot of methods here, right? So if you go and look at fill, right, you'll notice that there's lots of different versions of fill. So there's a version of fill that works with arrays of Boolean. There's a version of fill that works with arrays of char, one that of double. Sorry. There's a version of fill that works with int, right? This is very. No, that's not true. Sorry, I was thinking of a different language. So a method with the same name in the same class is called an overloaded method. The reason you can have these is because the parameter types, they're all different, right? So here you have a fill method that takes in an array of int and has an int value, right? Here's the one that has a float array and a float value, right? Double array, double value. So if the parameter lists are different, you can have the method name with the same name, right? And so what the arrays class does is it overloads the fill method so that there's a special fill method for every primitive type. So when you call fill and you pass in an array of int, the compiler can figure out which version of fill it needs to call. All right, any other questions? All right, not seeing any. What am I doing here? To fill an existing array so all elements have the same value, use the method fill. Didn't I just do this? Oh no, we went backwards, sorry. Okay. Right. There's the fill method right there. The number of elements in the array is stored in what's called a field. And this for arrays, the field is public and it's said to be immutable, so you cannot change the field. Right? The field name is called length. Right? So length is a read-only value, right? And it stores that number. It stores the length or capacity of the array. Right? If you try to write collection.length equals some other number, the compiler will flag that as an error. Right? So the compiler enforces the immutability of that value. Right? It can never change. This is nice because you can always get the length of an array. So rather than using the len function from Python, right, to get the length of an array, you just write dot length. The values in an array are called elements. So just like a Python list, we say the elements of the list, right? You also say the elements of the array. In Java, the index is strictly positive, strictly non-negative, sorry. So the first element has index 0. The last element has index length -1. So in this case, it's 9, right? For an array of length 10, right? So you have to use a valid index when you're trying to access or change an element of the array. If you use an invalid index, an exception is thrown in Java. So here's an example using my array collection, right? So collection has length 10, right? I can go through and change all the values to 100, right? Instead of using fill, right? I can manually go through. I can set the first element to 100, the second element to 100, and so on up to the last element, right? If I want to get an element, right, I can write x equals collection 0, right? And that assigns whatever value is stored as the first element of the array to x. If you try to use a negative index, or if you try to use an index that's too big, right, you immediately get what's called an array index out of bounds exception, right? So this is similar to exceptions in Python, right? When an exception is thrown in Java, the program stops running immediately at the point where the exception occurs. Right? So the exception occurs right here. So if this was an actual running program, the program would stop running from here and something would happen. Right? So it's actually the same sequence of, it's a similar sequence of events that happens in Python. And I'm not sure how much they told you about exception handling in Python. But we'll talk a little bit more about exceptions later on. Okay, so in Python, you've got this super handy for loop, right? So Python uses a for each loop, right? That's the only type of loop Python. That's the only type of for loop that Python has, right? So it's always something like for each element in a list T, right? And then inside your loop body, right, you're allowed to use the name elam, right? And you know that that just refers to, in this case, when you run this loop, right, elem refers to the first element in the list, right? The second time the loop runs, it refers to the second element. The third time the loop runs, it refers to the third element, and so on and so forth. Right? So if you want to find the maximum value in a Python list, right, you should not write it this way. There's a mistake here somewhere. So we start out by saying that the largest element is going to be the first element in the list, right? Then we're going to loop over the elements in the list. If any element is greater than the current largest value, right, we set high equal to the current largest elem. There's something wrong with this indenting, isn't there? There is. I just noticed that. That indenting's off by 1. There we go. Right, and then after the loop runs, right, so after you've looked at every element in the loop, in the list, you have found the highest element in the list. Now, the error in this function is that your list might have size 0. Right, so if your list is empty, that immediately raises an exception in Python. So really, there should be a statement here, an if statement that checks if the list is empty. If the list is empty, you should manually raise the exception. Anyway, this is good enough for our purposes. So Java has a for each loop as well. It was actually added fairly late to the language, so it didn't show up until the 5th version of the language, the 5th major version of the language. Right. So if you want to write a static method that looks like the Python version of max elem, this is the way you would do it in Java. Right. It's public static for now. We're going to find the max of an array of double. Right. So I need to return a double. Right. Notice the name. I'm using the Python naming convention here for a method. Right. Starts with the lowercase letter. It's a multi-word name, so I capitalize the first letter of the second, third, and fourth, and so on word. Otherwise, the code looks almost the same, right? So I create a variable called hi. I set it to the first element of the array, right? And now I have my for each loop. So the syntax is a little different, right? So a Java for loop, right? The control part of the for loop, that always appears inside of round brackets. Why are you returning a double if it's the index? It's not the index. Oh, hey, no, it's max elem, right? This is, did I screw that up? No. I'm not returning the index of. Oh, wait, did I manually find? No, I'm looking for the maximum value in the list. Right, I'm actually looking for the maximum value, so I have to return a double because this is an array of double. Yeah, I'm going to do the max element. I'm going to do the index next, I think. Right, so the syntax is a little different, right? You still read it the same way. So for each element named elem in the array, right? But the notation is different. So I use a colon here between elem and array, right? So that's the array name. That's my loop variable. I use a colon between them. I have to say what the element type is, right? But otherwise, it works the exact same way. Notice that Java uses braces instead of indentation, right? So here I've got braces here to denote the body of the for loop, right? I've got braces here to denote the body of the if statement, right? The scope of elem is the body of the for loop, right? So outside of these braces here, I cannot use the name elem. So elem exists only inside the body of the for loop. Right. So the for each loop in Java works the exact same way as the for each loop in Python. Now, you know that in Python, if you want a counting style loop, right? So if you want to count over the, oh wait, I think I'm going to do that next. Oh, here we go, right? So in Python, if I want to find the index of the largest element, right? And so instead of finding the largest element, I want to find the index of the largest element. I can use a counting style loop. But in Python, it's still for I in, right? And then you create an object, right? A range object that knows how to count from 0 up to length t minus 1, right? So there is no class called range in Java, which means you cannot write a counting style loop in this way in Java, right? So if you want to write a counting style loop in Java, then you have to use a different form of the for loop. Later on in the course, I'm going to show you how to make a class called range that lets you write a for loop like this in Java. The reason it's not there is because it's inefficient compared to the next type of loop that I'm going to show you. Right? It's inefficient in Python too, right? So in Python, you have to make an object, right, that corresponds to the this range from 0 to t, the length of t, right? And then you have to underneath the hood, Python's actually calling a bunch of functions on this, a bunch of methods on this range class, right? So it turns out that's actually there's a lot of overhead in that. So the second kind of loop in second kind of for loop in Java is the, I guess, the classic or the original style of loop, right? So this form of loop is inherited from the C and is inherited from C, right? The C programming language, and C probably inherited it from a different programming language. So when you want a counting style loop, it ends up looking like this, right? So there's three parts to this loop. There's the initialization of the loop variable, right? So I'm going to make a loop variable called I. Its type is int. It's going to start with a value 0, semicolon. So the semicolon has to be here. I want the loop to run as long as I is less than the length of the array, right? So this is called the loop termination condition, right? When that condition is false, the loop stops. Semicolon. So the semicolon has to be here. The third part is what's called the loop update condition. Right? So the loop update condition is what happens at the end. So right here, right, at the end of every iteration of the loop. Right. So at the end of every loop iteration, I increase the value of I by 1. Right? So that's how the counting style loop works. So I'm going to take it apart now and tell you about each piece. Right. So the normal for loop in Java has 4 parts, right? Part 1 is called the initialization expression. Part 2 is called the termination condition. Part 3 is called the update expression, and then there's the loop body. Parts 1, 2, and 3 are technically all optional. So it's possible to write a loop that has none of those parts, but it's a little unusual to do so. I'll show you how to do so in a little bit. But it's odd to not have all 3 parts. Right? You need the semicolon separating the parts. Oops, sorry. Initialization expression, that initializes the loop variable, right? So it runs exactly once when the loop begins, right? So before the first iteration of the loop, that thing in red runs, right? So we set the value, we declare a variable named I, we set its value to 0. Termination expression evaluates to true for the loop to run, right? The termination condition is checked before every loop iteration, right? So we've initialized I to 0. We now check, is I less than the length of the array? If it is, the body will run, right? If it's not, then you end up outside the loop, right? So the loop body does not run and the loop stops running. So whenever this condition is checked and it's false, that's when the loop stops running, right? Finally, the update expression is evaluated after each iteration of the loop, right? Normally, that thing there changes the loop variable there, right? It doesn't have to, but normally that's what it does, right? Similarly, the termination condition, normally that involves the loop variable as well. It doesn't have to, but normally it does, right? Now, I++, if you don't know what that means, I think you know what that means. I think I++ works in Python. It's the same thing as I equals I+1 or I plus equals 1, right? They all, in this case, they all mean the same thing. You could also write plus I if you like, right? In this case, there's no difference. Oh, sorry. What if we wanted to update the value of I to 2 or any other number? You mean in the update condition here? So if you want to count in increments of 2, you just change the update condition. So you could write I equals I plus 2 or I plus equals 2. They both mean the same thing. Right? So you just need to write some expression that changes the value of I, that increases the value of I by 2. All right. So the question now for for programmers coming from Python to Java is, the for each loop is really nice, right? It's nice. It's easy to write, right? You're familiar with it from Python, right? So why on earth would you ever write the counting style loop, right? And the answer is the for each loop can only access one element of the sequence at the same time in the loop body, right? So in the for each type of loop, you only ever have access to one element of the, in this case, the array, right? There are many types of computational problems where you need access to more than one element of the array or sequence at the same time. If that's the case, right, then it's normally easier to use a regular style loop. Right? It's not impossible to use the for each type of loop, but most Java programmers will then flip to the counting style loop. Right. So if I want to test if an array is sorted in increasing order, right? So from smallest to largest, I need to compare every pair of adjacent elements in the array. Right. I need to look at the first and the second element and check if they're in the right order. Then I need to look at the second and the third element and check if they're in the correct order, and so on and so on. Right. So to do this with the loop, right, I want to, right. So I need to look at two elements of the array at the same time. Right. So I'm going to start, right, with initializing my index to be 1. Oh, sorry, that screws up. Right. So I'm going to start at index 1. Right. And I'm going to continue as long as the index is valid, right? So as long as it's less than the length of the array, right? And I'm going to compare the element at index I with the element at index I minus 1. Right? So in other words, is the previous element greater than the current element? Right? If it is, then the list is the array is not sorted. Right? So I set is sorted to false. Right? Now you could write this another way. Right? You could start with 0, so I equals 0. Right? Here I would say if array I is greater than array I plus 1. Right? Now if you write it that way, you have to change the termination condition. Right? Because you're using an index of I plus 1 here. Right? So your termination condition has to be I is less than the array length minus 1. Right? So when you're working with arrays, you're always concerned, is the index that I'm using valid? Right? So if you're subtracting 1 from I, you have to make sure that I is never 0 or less. Right? If you're adding 1 to I, you have to make sure that I is never equal to array length minus 1. Right? Otherwise, when you add 1 to it, it becomes an invalid index. Right? So in a picture, this is how this is how the method works. Right? So iteration 1 of the loop, I compare the elements at index 1 and 0, right? So is 12 greater than 13? No, right? So we continue, right? So we update I, so I is now 2, right? So is 13 greater than 14? The answer is no, right? Update I, right? So I is now 3. Is 14 greater than 15? The answer is no, right? And you keep on going, right? So now we're all the way down here, right? I is 14, right? Is 25 greater than 26? The answer is no, right? So here I is equal to 15, right? So that's equal to the length of the array minus 1, right? So this is the last time that the loop will run, right? Is 26 greater than 27? The answer is no, so the loop is now done. It's looked at all pairs of elements, and is sorted is true, right? So this returns true. Now, if you have a list that's not sorted, right, there's no reason to look at all of the elements in the list, right? So in other words, once you find a pair of elements that are out of order, you can stop the loop, right? So if I find a pair of elements that are in the wrong order, I can use a break statement to break out of the loop, right? So break immediately breaks out of the loop, causing program flow to proceed to the statement after the loop, right? So break in a for loop causes the flow to go to here, right? So the loop stops running, and control flow goes to the point immediately after the loop, right? So as soon as I detect that the list is not sorted, I can return false, right? What you cannot do, right? And I see this still in people who are taking 200 or 300 level courses, right? If you want to check if the list is sorted, you cannot return true from inside the for loop, right? Can't do it because you don't know that the list is sorted until you've looked at, you don't know that the list is definitely sorted until you've looked at every pair of elements in the list, right? So you can end early if the list is not sorted. Whatever you do, you cannot return true inside the loop, right? Because you need to look at every pair of elements, right? So there's no way to abort, there's no way to stop looping over the elements and returning true, right? It just doesn't make sense. So you have to pay attention to where you're returning from inside the, if you're returning from inside the loop, right? You could also return false here if you wanted to, right? So instead of breaking, you just return false, and that would also work. So in this example here, right, I've got, this is the list is, the array is sorted up until this point here. Right? So when I reach this point here, right, I is equal to 3, right, I compare these two elements of the array, right? The element at index I minus 1 is bigger than the element at index I, so I can break out of the loop and then return false in this case. Here's another example of accessing more than one element of the loop at the accessing more than one element of the array from inside the loop. Right. So here's another example where you probably don't want to use a for each loop. So I want to check. Sorry, in this case, I want to reverse the elements in an array. Right. So I want to swap the first and the last elements of the array. Then I want to swap the second and the second last elements of the array. And then I want to swap the third and third last elements of the array, and so on and so forth. Right. So the way I'm going to do that is I need the index at the front of the array, right? And I need the index at the back of the array. Okay. So the index at the back of the array, I'm going to call j. Right. So to begin with, it's going to be the index of the last element. Right. Inside the loop, I is going to be the index at the front of the array, right? So I'm going to start at index 0, right? And now inside the loop, I want to swap the elements AI and AJ, right? So this is just the standard swap, right? This is the standard 3 lines of code. You need to swap 2 values in most programming languages, right? So I'm going to remember the value of AI, right? And store it in a value called temp. Right? I'm going to change the value of AI to be equal to AJ, right? And then I'm going to set AJ to be equal to temp, right? So that swaps AI and AJ. Right? So that's what I'm doing inside the loop. Now, which values of I and J do I want? Which indexes I and J do I want to swap? Right? Well, I want to swap 0 and length minus 1. Then I want to swap 1 and length minus 2. And then I want to swap 2 and length minus 2. Isn't it going to give the same array back? Nope. You'll see in a second, right? I'm going to let the loop control the value of I, right? So it's going to be 0, 1, 2, 3, 4, 5, and so on, right? Because I have I++. I'm going to manually control the value of j, right? So at the end of the loop, I decrease the value of j by 1 each time, right? This part up here, this increases the value of I each time. Right, so I goes up, J goes down. I goes up, J comes down. I goes up, J comes down. Right. Adam, I'll answer your question in a second. Right now, the trick to this is how the loop stops. Right, is the loop termination condition. Right. Instead of writing I is less than the length minus 1, I'm going to write I is less than J. Right. So as long as index I is in front of index J, the loop will run. Right? As soon as index I passes index J, I'm going to stop because that's going to start to undo the swapping, which is what Gurpreet was asking about. Or can you run the length, the loop length divided by 2 times? Yes, you can run the loop length divided by 2 times as well. Right? So you can also change this termination condition to be I is strictly length less than the length minus 2 divided by 2. Right? What time is it? 10:16. Okay. Adam is asking, can I put J minus minus in the update part? And the answer is yes. So let's I'll look at that in a second. Right. So this is a picture of how this method works. Right. So at iteration 1, I is 0, J is the length minus 1. Right. So I'm going to swap the 12 and the 27. So I swap those values. Right. So 27 is now in front, 12 is now in the back. Right. I update the values of I and J. Right. The termination condition is I less than J? The answer is yes. So we run. Swap these 2 values. Right. Increase I by 1. Decrease J by 1. Is I less than J? The answer is yes. So swap. Right. And you keep on going until you reach this point here. Right. So is I less than J? Yes. So we're going to swap these 2 values. Right. So we're going to swap the 20 and the 19. Right. Now, I'm going to increase I by 1. So I is going to be here. I'm going to decrease J by 1. J is going to be here. Right. Is I less than J? The answer is no. So the loop doesn't run. Right. And so this correctly reverses the elements of the list. Now, can I put J minus minus in the update part? The answer is yes. Right. And in fact, I can even put the initialization of J in the initialization part. So in this example, I and J, they both have the same type, right? They're both int. So I can initialize them in a single statement, right? So I can write int I equals 0, comma, J equals a length minus 1. If they have different types, you can't do this. So there's no way to initialize 2 variables of different types using this syntax, right? If they have the same type, you can separate it with a comma and say J equals length minus 1, right? Now in the termination or in the update part, I can use a comma to separate the 2 statements for changing I and J, right? So you can also write that previous loop in this way here, right? I and J have the same type, so I can initialize them here. If they have different types, you can still do the updates in the same here as well, right? But each update expression has to be a single statement. I'm going to stop there because we're at 18 after the hour, and I will do the last example in the beginning of the next lecture. I guess we have a little bit of time if anybody has any other questions. Anybody? All right, so I'm not seeing anything. So I'm going to stop the recording and end the meeting.